bit about me. I'm a Python and more recently Ruby developer. I worked previously at Microsoft. I came from an acquisition of Citus Data, and we did Postgres, distributed Postgres service. And now I work at Crunchy Data. It's also a Postgres company. And what I'm doing there is building Postgres as a service and a multi-platform one, so you can create your Postgres as a service with an Azure or AWS or Google Cloud server. I've been working with Python and Postgres for a while now. I've always been kind of excited, weirdly, about Postgres and performances. And that's kind of how I came to giving all these talks about performances, about what you can do, about indexes and stuff like that. So I hope that today I'll be able to give you some information that you will use in the future. So a little bit about today. So the first part will kind of be an introduction on what can cause performance issues in our Django applications. And in general, I guess in any application using ORMs, I'm focusing here on Django because that's what I used for a very long time. So I tend to enjoy it a lot. And the second part will be how to debug them, how to catch them, and most importantly, how to catch them before they reach production, which is nice, I think. And then we'll go through 4 very common cases that we can encounter. One is having loops of queries that then can slow you down. One being around limiting your query sets. And then it will be a little bit about pagination, and lastly, what to do when you have one specific very slow query, but you don't really know why. Sorry. So first, what can cause performance issue? I personally really enjoy ORMs. I know that a lot of people working with databases, a lot of DBAs tend to say that ORMs are, the devil and things like that. But I actually really enjoy just object mapping is so nice. Being able to get, your data from your database, but, get an object in Python and be able to manipulate it the way you want is very handy. Like as developers, we really need that. The problem is that it can be tricky. We have to be careful because sometimes you will end up with queries that you don't expect. They tend to sometimes execute queries that you don't see at first. Some of those queries might not be optimized, and you won't know about it if you don't learn how to look at queries and learn how to recognize what is wrong with a query. And lastly, I think that's something that can happen to a lot of developers is you're working on your dev environments and you have less data than on your production environment, or it's only you, so you're not 100 or 1,000 customers going on your app. So the load that your database is under is much less. So something that seems to be very smooth, very fast on your dev environment can end up being a problem on production. So that's really what I think happened a lot to us when we develop apps and what we need to be careful about. So the question here is, okay, cool. We know that we can have problems with ORMs, but how can we catch them? And more specifically, how can we catch them using Postgres? So one tool that I really like and use on all of my productions and devs is pgstat statement. It's a Postgres extension. If you're not very familiar with Postgres extensions, the idea is that it's not something that you have to install on a server. You can use a command called create extension. And so if you do create extension pgstat statement, it will install pgstat statement on your environment. And then you have to change a little bit the configuration in your Postgres. But if you are working with cloud like offering, you will probably actually already have pgstat statements. I am kind of curious about what you're using for your Postgres databases. If you can put in the chat, like whether you have your own service with your own servers, or if you're using cloud. I'm just curious about it. So what pgstat statement does is that it tracks statistics on the queries that are executed by a server. It's really useful. I will show you in the next slide how to catch slow queries using pgstat statement. I really recommended using both in production and dev. I know that it can sound a bit scary to add, something that is tracking queries, because it feel like it could slow it down, but it's actually not. It's very smooth, and I've never had problems with performance with using pgstat statement. And the other thing is, if you worry a little bit about pgstat statement and performances, what you can do is you can actually configure the number of queries that you want pgstat statement to save. The default is 5,000. And if you want less or if you want more, that can be something that you can put in your configuration. So using pgstat statement here, for example, I'm trying to get the 100 slower queries. And so I'm, selecting the total time, the minimum time and the maximum time of execution, the mean time, the number of calls that a query has been called, and the query in question. So what I get is records that look like this. So I have the total time that is here 643 milliseconds. The minimum time was 256 milliseconds and the max time was 531. It's been called 3 times and it's a select count. And we'll talk a little bit more about counts when we'll talk about paginations. So in a little bit. One other thing that I have used a lot, and I've been using it less lately, I'll explain why, but I've used it a lot, is the Django debug toolbar. I don't know if any of you are familiar with it, if you've been using it before, but it's the idea is that when you are, loading your view, you can add this Django debug toolbar. And it looks like this. So you have the SQL queries that have been executed. And the very nice thing is that it helps you track where in your code the queries come from, which makes debugging so much easier for developers. So yes, sorry, I talked and forgot I had this slide to explain. The other thing that it does is that it gives you the explain plan of a query. I will go through what an explain plan is at the end of the talk, but the idea of what it is that it's telling you how Postgres is doing to actually execute it. And it gives you information on whether the query is using an index or not, if it's looping to get the results, things like that. So you should also only enable Django debug toolbar when you're in debug true. That's very important because otherwise you could have those queries displayed in your production, and then you would have, customers or hackers being able to see the queries that are executed in your code. So you don't necessarily want that, but it's overall a very nice tool. I really like it. The problem with the Django debug toolbar is that it's not necessarily enough. One of the problems that you will have if you use Django debug toolbar, and if you have some JavaScript executing queries, like if you have Ajax calls, is that it won't track that. It will only track views and templates, but nothing else. So if you have something like, Ajax call to API endpoint, then you won't see those queries. And that's where I would recommend, if you're doing more, especially if you're using React or this kind of tools, to actually look into the Postgres logs and configure them at least locally so that you can see absolutely everything that is happening. It's also, I personally, one of the reasons I like working with Postgres logs is because I work with Ruby, but I also work with Django apps. I we have a Go application. And so when you're switching environments, and if you have to figure out for each environment, the tool to track your Postgres logs, it can be kind of annoying and boring. So having one common tool for everything is pretty nice. So here is what you would change in your Postgres configuration to have your logs. So you would put here log statement equal all, logging collector to on, and then the log min duration statement to 0, meaning it will log anything that is more than 0, taking more than 0 millisecond, which is everything. So a warning, don't ever do that on production, because one thing that you could end up with is gigantic log files on your production. If you enable all of your Postgres logs on production, then it will, like, you can imagine what happens if you have suddenly like 1,000 people using your app, and it's for this, each of these 1,000 people, it's doing, you know, maybe only 10 or 15 queries, but then you have 15,000 queries in a log file somewhere, and this goes on and on and on, and you end up with gigabytes of files, and that's not, for say, a Postgres problem, but it will definitely be a problem eventually. So be careful about not putting, like, enabling all of your logs on production. Okay, so now a few issues that I've run into in my developer life. And the first one is loops. I don't know if any of you have had problems with loops and queries, but here is, it is. Before I go into that, what I did for this talk, because initially it was supposed to be a workshop and I was supposed to, you know, work with people and explain, like, you know, give that app and debug all together with computers. So I created actually a Django app that you can download over there and install. And if you want to have fun recreating the issues that I've had or fixing it yourself, you can actually download it. But I'll just show you the model. Oops, I went too fast. No, okay, sorry. So the schema here. So we have, it's a pretty standard application, multi-tenant application. So we have companies that create campaign with ads, and we are tracking the clicks and the impressions of people. So you just have each, you know, you have a foreign key from campaign to company. You have also a foreign key from ads to campaign, and you have employees that are working on campaigns. So it's a many-to-many between employee and campaign through campaign collaborators. Sometimes it stopped working. Okay, so I have a list of campaign that you can see here that I can scroll through. And each campaign has ads. So here is what happens. Here's the code for that view. It's a simple list view with my model campaign and my template name. And in the query set, I'm just filtering on the current company. Like I assume that the person who's logged in is an employee from a company. And so we filter on the company from that employee because we don't want him to see the campaigns from other companies. Yes, sorry. So the number of queries here is surprisingly a lot. It's 101 queries. And when you look at those queries, a lot of them are very similar. I have 96 similar queries warning from the Django debug toolbar. It's something that you will notice when you're using this debug toolbar. It's this similar queries. What I'm doing here is using the fact that I have those similar queries. What I can do is see that it's, oops, sorry, I paused the video at the wrong time. But the Django debug toolbar is helping me track where the queries come from. And where the queries come is from this bit of code in my template. So the reason here is that I have a first loop for campaigning campaigns. And then I have a second loop to be able to show each ad for each campaign. So I have two loops for campaigning campaigns and for ad in campaigns.ads.all. And this double loop, so for each campaign, I'm actually going to query the ads. And so here I have 96 campaigns, so I have 96 queries. If I had 1 million campaigns, because I'm not paginating yet, I would have 1 million queries, and this would not be great. So what I do here, loops are actually really easy to fix with Django, because it gives you have two tools. You have select related that we use for foreign keys, and prefetch related that are for many-to-many or related objects. Here I'm using select related, prefetch related, because for each campaign I have many ads. What it's going to do is that it will generate 2 queries. So instead of having 100 queries, now I have 6 queries. When I look at those queries, I have 1 query that is for company, like the campaign query, and then I have 1 query for the ads. And so instead of having 100 queries, I have 6. It's a pretty good improvement, I think. So this is the kind of thing where, like, if you have on your local environment 6 campaigns, you'll be like, oh yeah, I have 6 queries on that view. It's great. Everything's fine. And then you go on prod and you have hundreds and hundreds of queries. So try to have maybe enough data on your dev environment for it to be meaningful. Like, I'm not saying terabytes of data, that would just be too much. But enough so that you can see if something is wrong before you end up with those loops on prod. So one thing that can help you catch those is, again, with pgstat statements, because it records the number of calls that a query has been used. So you can easily have a count on that. And so here, like, if you run that query and you do select query calls from pgstat statement, then you will have the 50 most used queries, and that can give you an idea of whether something is wrong. If you don't use pgstat statement on prod, I would recommend just enabling it, and maybe in 2 or 3 days, look at this query, and it will help you find out if there's anything really off in your prod. If you see one query being called 1 million times and it doesn't seem like it should, that can, help. So yes, I can't say it enough, just loops, be careful about them. I've seen so many of my apps be super slow because of them. So the second part that I will talk about is limiting what you're selecting. And by limiting, I'm not even really talking about limit 10, meaning like just, using the 10 first objects. I'm talking about selecting only the columns that you need. So by default, the Django ORM assumes that you will need everything from the table that you are selecting from. So it will do, if you look at my prefetch related from before, it executes that query where I just get, everything, the ID, the name, campaign ID, et cetera, et cetera. What I'm actually using in my app is just the name, the ID, and the campaign ID. So I need only 3 columns, not 2, 4, 6, 8, 9. So the query should look like this. Like, if you were actually writing your own SQL for that query, you would just select those 3 columns, mostly because you're lazy and you don't want to write all the column names, but also because the more data you retrieve, and especially if you have bigger columns like text, the more data you retrieve, the more bits it is to go through network. And so that can also slow you down a lot. So the great thing of the Django ORM is that it does have a function only. So you can just use it and give the list of columns that you want, and that's it. It's really just super easy to filter that. It's just maybe a lot of work if you haven't done it before, because you have to do it a little bit everywhere at first. But it's pretty easy to do. The only problem is that so yes, I'm showing here an example of using only and passing the name. The only problem here is that, as I was saying, we are using prefetch related because we are, getting the ads from the campaign. And so if you want to actually use only for that, you have to it's a bit trickier because you have to use the prefetch class. So what you do is actually import prefetch from Django DB models. And then instead of having the normal prefetch related with just ads, you're going to add prefetch and then give the query set being ads objects all, and then only ID, campaign, and name. So which are the columns that you want. So that's the difference between when you don't have prefetch, when it's your normal query, where it's like, ads.objects.all, then you can just use only. And then if you want to do it on a prefetch or a select related, then you will need to import that prefetch class. And now on for pagination. It's actually a subject that I'm excited about, paginations, because it is so important, but Django does it wrong. And I love that. Not really, but I actually kind of just enjoy talking about it because it's a very weird thing. So to have that work, I now generated 1 million campaign for my company. I have a company that is advertising a bit too much, if you want my opinion, but sure. So the list page is now very, very slow. And you do have, because we don't have pagination, you don't have a page with 1 million items, which is not really interesting. So why is it important to paginate? As you can guess, retrieving data for 1 million rows is slower than for 25 rows, just because you have a lot of data that you have to pass through network. And that's really just, it can't be fast. So the more rows, the slower. And also our prefetch related was using an in the query. I don't know if you've noticed, but it was select ads where campaign ID in, and then the list of IDs. So we go from, 25 values to 1 million. And a query with an in and then 1 million values is also not great. You should not have that. If you have that, that's really bad. So you should paginate. The other thing is you actually never need to see all the rows. I feel like it's the thing that I've had so much from colleagues of like, oh, but what if people want to see everything? I'm like, no one wants to see everything like in one view. Like no one wants to see 1 million things. You would just get bored after 10 of them. We get bored very fast. So the Django has a paginator class that is taking care of splitting a query set into pages. It's just very easy. And here is how you use it. So you have a query set here that is campaign filter on company ID, because it's again my campaign query. And what I'm going to do is use that paginator from Django core paginator, give it the query set, and then the paginate by, and here I'm doing 25. The number of pages is 40,000. And then I can get pages. So the page 1, and I get that page and it has a next page. It doesn't have a previous page. And then I can get the next page number. And a page has an object list with the rows from that page, really. So the first 25 rows in that case. So here is how to integrate it to a list view. It is overall pretty easy, mostly because it is already integrated in list view. So the only thing that you have to do is add paginate by 20. That's pretty fast if you're using class-based views. And then you would want to have, next and previous pages in your HTML. So you would add a link here. So if the page has a previous, then you add the previous link. And then if it has a next, then you add the link to the next page. So overall, it's pretty easy. And so here is what it looks like. So I have my 25 rows, and then I have my next. And again, yeah. You have 7 queries here. This one is taking 100 milliseconds, and it's adding, so the way Django is doing the pagination is by doing limit your 20 or 25, depending on your pagination, and offset 20. I want to pause here, if I can, to explain a little bit. Here I'm going from the first page to the last page. So my last page, because I actually paginated by 20 and not 25, I lied to you previously. So my last page is the page number 50,000. And suddenly my query that took 100 milliseconds is now taking 398, so 400 milliseconds. It's taking 4 times this, like it's 4 times slower than when it's the first page. And that is weird. And the reason is because it's using limit 17 offset something, a big number, 9 million, no, 900, whatever. It's numbers are difficult. So offset is really a terrible thing to use. Honestly, you should never use offset anywhere. The reason why offset is so slow is that what it's going to do is it's going to load, if you said offset 0 limit 20, it's going to load 20 rows. If you said offset 20 limit 20, it's going to load 40 rows and give you the last 20, because it needs to be able to find that offset. It needs to go through all of the rows and find the number 40, the number 20 to 40. So when you are at that last page, you are actually loading those 1 million rows, and Postgres is returning you the last 20. So offset is terrible. It is the default in Django, and I wish it would change because there are better ways. The other thing that Django is doing is that it's using a count that is actually also very slow. That count is used to know the total number of pages that you have. So it counts the number of rows and then divides by your paginate by. And counts are also really slow. In Postgres, in any databases, in MySQL, it would be the same. If you can avoid counts, it is better. So what can you do to replace that default paginator? Because it's kind of weird to just say, oh, that's terrible, and it give you an alternative. So the best thing that you can do is use what we call key set pagination. Instead of doing this offset limit 20, offset 20, what a key set pagination would get like a query where the ID is more than something, a value, and then do a limit 20. If you want to know more about key set pagination and why offset is terrible, there is actually a pretty good website from someone named Marcus Venant. It's usetheindexluke.com. So to implement key set pagination, there is actually an app that you can use. It's it's the Django key set pagination plus. So what you do to have it running on your own app instead of the default paginator is, add it to your imports. And then it's just a mixin that you add with the paginate mixin. And then you give it the paginator class to replace the default paginator from Django, and then the paginate by. It is not that much work. I don't think so. I think it's doable. The big change is that you won't have the last page because it's not doing a count. So it's not allowing you to jump to the page 50,000. And so you will more add those infinite scrolls are most of them based on key set pagination, because you just see the next thing. So here is the difference now between my performance for this query. So I don't have the count anymore, and I just have this query where I do have the ID more bigger than, and this big number, and the limit 21. So here, this was my query that was 400 milliseconds, and it's back to being 100 milliseconds. So this is, my last page that was problematic. So yes, I recommend you using key set pagination. And last but not least, what if you have one single slow query, but you don't know why it's slow? So first, you can use a pgstat statement to get your slowest queries. That can again be, if you use pgstat statement on prod and let it run for a few days, you will easily get your slower queries from Postgres, and that's pretty nice. So here I am, getting those slow queries, and one of the slow queries that I see is the select from add analytic campaign where archived is not true, because I'm getting the campaigns that are active. It's taking an average 219 milliseconds. And now I'm going to use explain. The first time you will see an explain plan, you will find it terrifying, because it is terrifying. It's just a bunch of numbers everywhere, and it's very confusing. I actually gave a talk on explain for Django developers. I can maybe share you the link if you're interested. So here I look at this query plan, and to look at the query plan, I do explain, and then I paste my query. What it gives me here is that it's doing something called a sequential scan on add analytics campaign. What a sequential scan is in Postgres is that it's simply going row after row and checking if the row matches the condition that you have. So archived is not true is my filter. And that is slow because I'm going through every single row that I have in my table. So what I'm missing here is an index. Oops, someone is trying to enter, I think. Oh. So one thing that is really good about Django, and again, I should stop advertising for myself, but I did a talk for Django and indexes, because I'm actually pretty fascinated by indexes in Postgres. And so I did a series of talks on that, and one specific for Django. So one thing that if you don't know what index are, first I'm going to spend a few seconds explaining that. The idea of an index in Postgres is basically the same thing as an index in an encyclopedia. Like you're looking for everything about birds. And instead of reading your encyclopedia from A to Z, you go to the index, and it's going to give you the list of pages where you can find things about birds. And so you will jump to that. And the idea of an index in Postgres is exactly the same. You give it a column that it's indexing. In this case, we're going to index the archive column, and it's going to create a tree with, where you can find rows matching this or this condition. So what I'm doing here is, instead of having a normal index, I'm actually adding a condition, and I want to only index the rows that are not archived, so that are my active rows. And that's easy to do with Django, because you have this models index where you can simply add a condition. And so my query time now is 100 milliseconds instead of 260, I think. Yeah, it was 219, sorry. So I'm showing here only partial indexes, which is maybe not the most common usage that you will have. But if you want to know more about indexes overall, I think that my own talk is great. But it's just, I go through all the different options, like what to do with when you're indexing text. And that's something that might happen in your applications. I don't know what you're doing, but you might have some content that you want to index and you want to search for specific keywords, and text search in Postgres is possible, but if you don't know how to do it, then it's not possible, or it's very slow. So I am going to, right. So there can be also, maybe you're the most perfect developer in the entire world, and you fixed all of your slow queries, all of your loops, everything seems to be just perfect. And that can happen. Like if you've worked, if you've done the work on performance, there will come a moment where you're so successful in your application that maybe you just don't have enough disk, you don't have enough CPU. It's something is wrong. Like maybe it's time for you to scale up, meaning to add resource to your servers. And that can be tricky to figure out, especially if you don't have a lot of self-confidence and think that probably is from your app. But also sometimes, and really often, I thought that I was great and the Postgres server was wrong, but then it was the opposite. That has happened to me. But yeah, sometimes your hardware resources are not sufficient. To figure that out, that I recommend, if you have time, because it's a 45-minute talk, but you can play it, time 2 x2 on YouTube, so it's only a 20-minute talk. I recommend that talk from a colleague of mine. That is what is wrong, like how to recognize what is wrong, and what data should you be looking at. Should you be looking at your CPU usage, and what does it indicate when you have high CPU usage, and just how to recognize when it's time to scale up your server. That would be an entire new talk, which is why I just direct you to this one, because I don't think that I can really just go and explain all the different situations that can help you figure out what's wrong. But yeah, sometimes you just need to scale up and you can't really improve your applications enough to fix your Postgres problem. So in conclusion, here are the 8 things that I hope that you can take from this talk. The first is that pgstat statements will help you find your slow queries, but also your most used queries, because you have the number, the calls, the count of execution of a query, and you have the time of the execution of your queries, that it can really help you figure out which queries are problematic in your app. The Django default toolbar is really nice if you if you mostly use views in Django, views and templates, then definitely use Django Debug Toolbar. It will help you so much. And mostly what I love about it is just being able to trace back to where in the code the queries come from, and you don't even have to do that work. Because when you're using Postgres logs, that give you, 100% visibility into your queries, so you're not going to miss any queries, but you will still have to work a little bit harder to, do the link between the query and where it comes from in your code. And that can be sometime if you have gigantic views with a lot of calls and stuff. Be careful about loops, especially loops in loops, because they just can generate hundreds of queries and are tricky to debug. If you have time for that, and if you see queries where you're selecting text and that it's taking a lot of times and maybe you don't need all of your columns, think about limiting the columns using only. Replace your offset pagination. Honestly, that will help you so much with pagination. Using key set pagination is so much better. So no offset, would Luke say. Not Luke, I mean Marcus Wienand. He made like a little sticker with no offset. Indexes and partial indexes will help you. They will help you to a point because they can also trigger other problems. Like if you, sometimes you're going to actually miss indexes that you would need to increase the performance of to enhance a query. But sometimes if you start indexing all of your columns in a table thinking, hey, the indexes are great, you can end up with also very slow writes because indexes do impact somewhat the writes, because every time you write in your table, in the database, in your table, then you also need to write into your index. So if you start to think, well, indexes are great, let's index everything, then your writes are going to start to be slow. So indexes are great, but not always. Scaling up can be a solution if you've optimized all of your code and the server isn't big enough. It can also be, if you're in a situation, I would not recommend it to do too much, but sometimes you're going to be in a situation where you have a huge problem and you know you need to work on your app to improve the performances of your app, but you also need a quick fix. You can scale up your server and then fix your app and then scale down your server. That might be expensive. So thank you. And I put here the links to the different talks I mentioned and to the GitHub repo for the app I was using.